So binary tree, pre-order, in-order, post-order solution. So if I have 1, 2 and 3, if I were using uh, this recursion called stack, if I was doing recursion, so in that case it will be 1. Since I have visited 1 for the first time, I will add it in my pre-order 1 here. I will write in order also here. I will do it side by side so that both the solutions you will get to know how they are working. So then I will go to one's left solution, one's left child, which is 2. I will add it in my stack. Since I have visited it for the first time, I will add it in my pre-order. After that I will be checking for the 2's left child, which is null. And now I had a pointer which was pointing to the root initially, then it was pointing to root's left element, which was 2, and after that it was pointing to 2's left element, which was null. Non-null is not a node, so I will be going back to the stack top, and stack top is 2. So I will say that okay, see, left subtree of 2 is already visited. Okay, so now I have to visit 2's right subtree, right? So initially my node was pointing to this, but now my node should point to this. Now my node should point to this and not here. Now before this transition you will be seeing that I came from here. Now this is in order, right? This is in order. So before doing the transition, means before assigning my node from here to here, I will say okay, first add 2 in your stack, then remove the 2 from your stack. And after, why have I removed 2 from my stack? Because I don't care that I visit 2 for the third time or not. Means whenever I visit 2 for the third time, I don't care about it. I'm only concerned of pre-order and in-order, which pre-order means visiting the node for the first time, and this means visiting node for the second time. Since I already visited 2 for the second time, I will add it in my in-order. Then my node will start pointing to the right child of 2, and this is also null. Since this is also null, then what we used to do, we will say that which is the stack top element. This is 1, this is 1, right? So I will say that okay, now my node will point to 1, and I will remove 1. Okay, I will remove 1 if I get a null node. So first what I will do, I will stacks top element, then I will uh, remove the stacks top element. I will go to its right element, which is 3. Now my node should point to 3. And before this transition, when I uh, before I before my node starts pointing to 3, from earlier it was pointing to 1, now it's pointing to 3. But before this happens, as you can see, this is something in order, right? So since it is in order, so I will say that I should add 1 here. Now uh, now now my node is pointing here. Since 3 is being visited for the first time, so I will say, hey, you are being visited for the first time, so I should add you to my stack. So I have added 3 to my stack. Now I will go to its left child, and left child is null. Now my node will be pointing to null. After it's pointing to null, I will say okay, remove it. I will say okay. Now my node should point to the right child of 3. But before that, as you can see, it's in order. So I will put 3 in my in order. And since okay, I forgot to write 3 here. When we will write 3 here, when we visit 3 for the first time, it after my nodes starts pointing from 1 to 3, in that step only. So since I had done that step earlier also, so I believe I don't need to repeat that step again. So let us see the code. Now you can see that I am using stack because I need to do backtracking, and to do so I'm using stack. Now I am using answer stores, basically pre-order, and node is initially pointing to root. Okay, so if I had a node, let's take a corner case. If I had a node and actually a tree which is a null, means it don't have any node, so in that case, do you think I can travel array node? No, right? So in that case my node will be pointing to actually null, and this case will get executed. And first and foremost thing which I am gonna check is that, is the stack size 0? Yes, the stack size will be 0 since I hadn't added anything. I had no node, so I can't add it. So I will directly break it and return the answer. Okay, so let's come back to our same example again. So initially my node was pointing to 1. 1 is not a null node, right? So this statement will be executed. So when, what things we used to do, we used to add 1 to our stack, and since we are visiting it for the first time, we will also add it in our pre-order. So yep, we have added 1 in our pre-order, also one added 1 in our stack. Now what we used to do, we used to our node used to point to one's left child, which is 2. That thing also we have done here, correct? So now one time iteration is done. Now my 2 is a not null node. Okay, it's again a not null node, and when it's a not null node, it means that the node is visited for the first time. So since it's visited for the first time, I will add it in my pre-order, also in my stack. And now I will check for one's left child, which is null. So my node is pointing to null. Cross means null. Okay, so now my node is pointing to null. Then this traversal again done. Now in the third iteration, this statement will be executed. First it will check that is the stack empty. No, the stack is not empty, the stack size is 2, right? So I will say that okay, in case my node is pointing to a null node, which is not a node, so I have no choices left. So in that case, I will go to the top of my stack, which is 2. My node will start pointing here, and now my node should point to the right child of 2. But before my node starts pointing from the left child of 2 to the right child of 2, I will say that, are you able to see this thing? This is what? In order, right? So in order thing, you have to write that line here, that in order dot pushback pb node val. Okay, node val. This thing you have to write here, where you have to write just before you do, just before you starts pointing your node from the left child to the right child. Okay, so let me tell what all things I have done. Yep, and you don't need to erase it. So my left child is null. Left child is not a child, means null is not a child. So now my node, in that case, when I encounter a null node, I will say that okay, my node should point at the top, at the stack's top element, and then it should remove it from the stack. So it is, let's remove 2 from our stack. Why are we removing this? Because left child, we have already, left child, or you can say left subtree, we have already visited, but the right subtree we haven't visited till now. So if I get this element, then left child is already visited, right child's right subtrees root, and now my node is pointing to that. So 2 is useless for me when I am not finding post order, because post order required third time, but this solution doesn't deal with that. So I can remove 2 if I were finding the post order, then can I remove 2? No, I can't remove 2. Why? Because post order goes like this, right? Post order goes like this after visiting the right child of 2. But since I am not finding it, so I can simply remove 2, because this part, I am not doing that. Okay, so I am removing 2 from my stack. I am going to the right child. Now the my right child is again null. So what you have to do when your right child is null, your node will be pointing to the top of element of the stack, which is 1 again, and now 1, we will go to one's left child. We were sorry, the node is pointing to 1. After that, after that we will remove 1 from our stack. And we will go to one's right subtree's root, that is 3. Okay, but before that, can you see this? Before pointing node equal to 1, so no, to node equal to 3, can you see this? So this is in order, right? So before doing this, before doing node is equals to node dot right, or node uh, pointer right, I will say that uh, I should have added in order dot pushback. Okay, and after that I will be visiting to 3's left. 3's left is again null. 3's left is again null. So since I am visiting 3 for the first time, I will add it in my pre-order. I will add in 3 here also. Then 3 is here. Okay, then I will go to 3's left child. 3 doesn't have a left child, so my node will be pointing to something null, and null is not a node, as I already told. So 3 is on the top of the stack now, so my node will be pointing 3. I will remove 3 from my stack. I will now my node should point to the right child of 3, right root of left sorry root of right subtree of 3, which is actually null. But before that, as I already told you 2 times, this is in order. So now you need to add 3 in your in order. Okay, which is somewhere here. And now your node will be pointing to this, and that iteration will also get completed. Again you will get into this case, and you will find that your node is null this time, and your stack is also empty. So you will say that, okay, I have visited a complete tree. So that is it. So this is the solution. This is pretty simple solution. If the node is not null, we will be adding it in my in our pre-order stack. We will push it in our stack and also visit the left subtree. If it's null, then we will check that, as we already traveled the left subtree. If yes, okay, break it. If no, then we will say that, okay, now time to visit the right subtree. So before we visit the right subtree, we will be removing that node from our stack. Since we are not finding the post order, we don't need that, because we don't need to find the third time visit of that node. And then we will be going to the root of the node's right subtree, which is node right. Okay, and in case of in-order traverse, as I already told that your node may be pointing here, and our node may be pointing here. If your node wants to point at the right, before doing it, you will be seeing that this thing. So in order, so before this, add this line. Answer means this is in order solution, right? So answer is basically storing right. Now in this solution I will be telling you in order, pre-order and post order. Okay, in order, pre-order and post order in a single code. So uh, in order to do this, since position post, in post order we have to visit the node for the third time, for the third time. Fine, so let's take the same tree again. And now I have one here. I have visited a one for the first time, so I will write it like this. Then my one calls two. I visit two for the first time, I will write it like this. Then I visit two's left, which is nothing. Now my node is pointing to two's left, which is actually null. Okay, so I will say that, oh, you are null, right? So okay, fine. Since you are nothing, so I will start, my node will start pointing to the top of the my top of the stack. Since my node is pointing started pointing to the top of the stack, it means that this node is being visited for the second time, so I will increase it to 2. Okay, now I will say that, okay, I will go to a, okay, so left child was null. When I have right child, before I change it, before I before my nodes start pointing to this two's right child, what I will do, as I already told you earlier, this is in order. How can you forget this? This is in order. So I will try add it in my in order, and after adding to my in order, I will say, okay, now my node can point to the right child, which is actually null. So now my node is again pointing to null. When my node is again pointing to null, what we used to do, we used to again go to my stack stop. Stack stop is now 2. Now it will be 3. It will be 3, right? And what does 3 means? 3 means we are visiting 2 for the third time, which means like this, which means like this. So this is what? This is post order, right? So now you need to add to in your post order. These things are pretty simple, and the code is similar to the earlier previous code also, so I will not take much of your time. So when you visit the node for the very first time, you will say that push it into a stack, mark it as 1. Okay, 1 basically means that we are visiting it for the first time. Then add it to your pre-order and go to the left child, same as earlier. Now in the else case, again this line again is the same. If stack is empty, then break it. If not, then if the stack stop 1 comma 1, okay, 2 comma 1. So if it is 1 here, it means that already it was visited one time. If it was already visited for the first time, it means that this time is the second time, and in second time we will add it in our in order. So we are adding it in our in order. Also we are updating it to 2, which means I am adding it for the second time. And now I will be going to the right child as we used to do earlier. Okay, now when I visit 2 for the third time, means it was already 2. Equal to 2 means the node was already visited 2 times. So this is the third time we are finding it. So if I have a node and I am visiting it for the third time, So now in order pre-order and post-order all things are done, so we can remove this node from our stack. So we are removing it from our stack. Also we are adding it to our post-order, and we are marking node as null. Why are we doing it? Why are we marking it as null? Because so that in the next iteration we access to stack's top element. We will remove it and we will go to stack's top element, and similar and the same things will go again and again and again. So this was the solution for in order pre-order post order in a single. So hope you like this video. In next video we will be seeing a new solution by tree level or a traversal. Before that, do like, share, subscribe. These videos take a lot of time. So thank you so much for watching. Like the video if you have watched till here. Have a nice day.